I'm Sumit Majumdar. I'm a pass out of IIT-JEE. I'm from the 2003 batch, and since then I am with askIITians. Today we'll be discussing about the topic about mechanical properties of solids. So what is the mechanical property? We see that there are some substances which are very hard. There are some substances which are very soft. Let's take the example of diamond and graphite. So diamond is one of the hardest substances that are known, right? It also has a particular shape in it. Similarly, if we take the case of a rubber band is also kind of hard, but if you try pulling it, after some time it basically breaks down. In the same way, you also have other brittle substances. So let's try to understand about those kinds of brittle substances in this particular chapter. So this chapter is basically going to constitute about, we'll be discussing about introducing the concept of elasticity. Then we'll further try to introduce about what are the different types of bulk modulus. Bulk modulus is nothing but how exactly on the application of the force, how exactly the body behaves. What are the changes in its dimensions, that is it can be changing in length, change in area, change in volume and so on. So how exactly that those kind of changes actually take place. Right? So then we'll further go on to what is known as a toughness. Toughness means how hard, how soft that particular material is, and then we'll conclude finally. Going ahead with the final thing, we'll be discussing about what is known as the thermal properties. Thermal properties as in the sense, like if we are applying the force, obviously there is going to be some change in the length, some change in the dimension. In the same way, if you are applying instead some amount of heat, what is the kind of analogous change that occurs? So this is broadly speaking that all we are going to cover. So stay tuned to continue for the same. So today we are going to start about the mechanical properties of solids. So what do the mechanical properties of solids actually stand for? As we are aware that we have always come across things like springs and other elastic materials. We say there is something known as elastic, right? So why do we call it as elastic? Because that has the inherent property of being elastic. Elastic means if you stretch that object, it gets stretched, but as soon as you remove that applied force, it comes back to its original state. Yeah. So that is what is known as the elasticity. Now this elasticity stems from the fact that there are some mechanical forces which come into play as a result. So let's try to understand about that. So the topics in this that we are going to cover are going to be elasticity. So the first thing is basically where we talk about the basic crux of the matter, where we talk about what exactly causes elasticity, what is elasticity, how do we define it, and so on. Then we come to the case of the spring. So if we come to the case of a spring, in the case of a spring, if you apply a force, the spring gets extended, and as soon as you leave it, the spring gets compressed. Correct? But this happens up to a particular value applied force and up to a particular value of extension. So that is what we are going to cover in Hooke's law. When we are applying a force that makes the spring get extended, obviously we are supplying some amount of energy in it. So the amount of energy that we supply in it is what is known as the elastic potential energy. So elastic potential energy is the potential energy stored in a spring because of elasticity, right? Then we define something known as a stress and a strain curve. So what basically does that mean? I'll give you an idea here. Stress we are going to come across. So stress basically deals with when we say that when you're applying a force, as a result of that, the object experiences a pressure. The force is going to be either tangentially applied or it's going to be applied perpendicular to the area, right? So as a result, what's going to happen? There is going to be a pressure produced. So pressure divided by how much is the change in length or how much is the extension in the length divided by its original length, that gives us the stress and the strain relation. Further, we define the different types of stress, that is shearing stress, bulk modulus, and the Poisson's ratio. So these are other properties that are going to come to us with regard to elasticity. So let's go further now. Okay. When we are defining these things, obviously we need to define this in terms of, for instance, solids. So what exactly is solids? Solid is something which has a definite shape. So if I say that I have, this is a solid thing. So this is a solid thing means what? This has a definite shape. If I say I have some liquid, so what I cannot really say that what is the shape of the liquid. The liquid is going to take the shape of the container, but it has a particular volume. In the same way, if I say that I have a gas-filled balloon, the gas does not even have a particular volume, neither does it have a particular shape. It will take the shape of the container or the vessel wherever you keep that gas, and it will also take the volume of that particular thing. But in the case of liquid, there is a fixed volume in it, though it does not have any shape. When we talk about a solid, it does have a specific volume and a specific shape. So if we say that in order to change, that is change the shape or size of body, you need to apply a force of significant magnitude. That is, you need to apply something which is very significant, such that it actually changes the shape. It's not that easy, because if a solid is bound by strong forces of attraction between the molecules, so you cannot really change the shape of an object very easily. The solid will have a definite shape, and to change a shape you need to have a very significant amount of force. So for examples, include rigid inside, from furniture to electronic appliances and all. These are all solids which have a definite shape, and you cannot really just by touching it you can change the shape. You cannot. You need to apply a significant force. Further, we now come to the basic case of elasticity. So what is elasticity? Elasticity is basically something, if I say there is a tendency of an object to regain its initial size. So it's the tendency that it comes back to its original, or it will prefer to come back to its original state, because it will have the least potential energy there. But this is going to be the case when you remove the external force. So as soon as you remove the external force, the body is going to come back to its original state. So that is what is known as elasticity. So elasticity comes from, let's say you have a rubber band, you stretch the rubber band, it gets pulled. So let's say you take the case of a rubber band. So I'll very bad in drawing. So let's say this is what is our rubber band. Now if you pull it, so let's say you're pulling it from here, you're pulling it from here, so obviously it will get stretched. So if I say, so it becomes somewhat like this. So it gets stretched. So when it gets stretched, obviously it becomes thinner, right? So it becomes thinner, but as soon as you remove this applied force, it will tend to come back to its original state. So that is what is known as elasticity. In the same way, you have pillows. So supposing when you sleep, you basically put your head over the pillow and it gets compressed. But as soon as you come out, or let's say you remove your head, it again retains its original state, right? So that is what is known as elasticity. Further, it may so happen that you keep on applying this force. For instance, if I talk about for the case of rubber band itself, so if I keep on applying the force such that the rubber band keeps on getting extended, and after a certain limit it breaks down. So when it gets broken down, it cannot come back to its original state, and just before breaking down as well, it is not really possible for it to come to its original state. So that is what is known as the tendency of an object to get permanently deformed. So it gets permanently deformed when you apply an external force. So that is what is known as the plasticity. So this is what is known as plasticity. So plasticity is like you have putty, you have plastic. So these are the things which get permanently deformed. So if you, let's say you have a ball of putty, you just deform it, you put it in some way, it will continue to remain in that state. It will not, even though it's a solid, it will not prefer to come to its original state, because there is no such original state there. In the same way, you have plastics. Plastics are also solids. They have a fixed shape, but they can easily be deformed, and once they have been deformed, they will not come back to its original state, right? So that is what is known as plasticity. Now, when you are applying the force, right? When you are applying the force, obviously, if I just say, I have an object here which has some area of cross section, I am applying some amount of force out here. So this is the area of cross section that I have. On this area of cross section, I am applying this force. So when I do apply the force, so as a result, there is going to be a stress because I need to apply the force from both ends. So if I apply the force from both the ends, the body will try to get compressed, or if I just try to pull it out, in that case the body will try to get extended, right? So as a result, you get something known as stress. So stress has the same dimensions as pressure, but it has a particular direction. If you talk about pressure, so pressure is going to act along all possible directions. So here it's not that it is going to act along all possible directions, it only acts along a particular direction. It has a particular direction, that is, the force is going to be applied along a particular direction, either perpendicular or tangential, right? So force per unit area results into what is known as stress. So how do we define it? So when an external force, mind you, it has to be external unbalanced force. If it's a balanced force, then too it is going to, because okay, how do I defining it? Here as well, the net force is 0. But since when you are applying the force at a particular area, you need to understand that at a particular cross section. So if I say this is area of cross section A1, this is area of cross section A2. Right? Even though A1 is equals to A2, the most important point is this: if you are applying the force on the area A1, that is going to deform the side of having an area of cross section A1. In the same way, when you are applying the force F on the area A2, it's going to deform the side A2. So irrespective of whether it is a balanced force or an unbalanced force, it is going to change the dimensions of the object. The body also exerts a restoring force to resist the change. So as soon as you remove this force, the body will tend to come back to its original state, right? So in that case, this restoring force that is acted upon by the body, that is what is known as the stress. So this acts in the opposite direction to the applied force. So stress is going to be force per unit area. As you can see, it's a kind of pressure because dimensionally it is pressure, but since it has a particular direction, so we specify it differently. Okay, now what are the different types or common types of stress that you can encounter? For example, if you talk about a simple tension, that is a cable. So you see that there is a cable. You see that there is a cable out here. Let me change the color of the pen. So this is my cable here. So as you see, this cable passes on this particular what you can say field. So when it is passed on, obviously it is under stress. So it is being pulled this way, it is being pulled this way, as well as it's being pulled this way. So there are two forces acting in opposite directions, right? So this results in this is a very simple tension that is acting here. This is acting on a particular cross section, let's say A0. So assuming that the area of cross section remains constant throughout this, so effectively the stress that is acting is going to be defined as F divided by A0. So this is what is known as the simple stress. Okay, now it can also happen that you have some rod. Okay, at the top end you try to rotate it this way, and the bottom end you try to rotate it in the opposite way. So there is a kind of twist that is involved, right? So that twist that is involved, that here it's a kind of an angular force or a torque that is applied, which results into something like this. So this is known as torsion. So torsion is effectively related to the torque, but here at a particular direction, because of torque, there is going to be some amount of force as well. So the force that is there on the surface is going to be Fs, and this results into a kind of torsion. So torsion is going to be defined as tau. So this has the same symbol, mind you, but this is not torque, this is torsion. So torsion is equals to Fs divided by A0, and this particular thing is what is known as the moment. So R, that is the radius that you have of this particular cylinder, into torque, into the torsion tau, into A0. So it's a sharp in A0. So this is equals to the moment that you get. Okay. Now let's try to understand Out of the following, which is the most elastic? Elastic means which tends to come back to its original state. So that is the one which is the most elastic. The first one is rubber, glass, steel, plastic. Rubber, if you extend, it will get extended. Glass is very brittle, so it's going to break down. Plastic is also brittle. It's basically going to change its state completely. Steel is something which is a metal and it will tend to come back to its original state, right? So C is the most obvious answer. Now let's say the maximum load a wire can withstand without breaking when its length is reduced to half of its original length. Okay, let's try to understand it, how it works. We define something known as the Young's modulus, which will come later on. So this is defined as the stress, which is equals to force per unit area, divided by delta L by L. Now if I am saying that this y is a constant, right? So if I just rewrite this, so this can be rewritten as F divided by A into L divided by delta L, right? So this becomes FL divided by A delta L. Clear? So if I am now saying that when its length is reduced to half of its original length, the maximum load a wire can withstand. Now y is constant, correct? So if y is constant, so we need to understand about what is the relation between the force and the length. So that tells me that FL is going to be a constant, right? So if FL is constant, so force is inversely proportional to length. Now if I say that the length is reduced to half, so if I reduce length to half, so this basically relation can be written as F1 by F2, that can be simply given by L2 by L1. Length is reduced to half, so this becomes equals to half, right? As a result, the new force F2 is going to be equals to twice of F1. So it's going to be double, right? So hopefully you understood the basic part of the mechanical properties. Hopefully there are no doubts. If you have any doubts, please let us know. Let's continue further in our next session. Thank you. In this part, we discussed about what all are the different types of moduli that we are going to discuss throughout the chapter. We also understood about how exactly the force is related to the different kinds of stresses that are produced. We will be discussing further on this in the next part. In the next part, we'll be starting off first with an introduction to understanding about the relationship between the stress and the strain. So what is stress? Stress is basically related to the force applied along a particular direction on the area. So force per unit area defines for us the stress. And as a result of that, what are the different types of strains that are produced and what are the different changes in the dimension that take place, that we are going to understand in the next chapter. So stay tuned for the next chapter.